Welcome back to our channel, Space Enthusiasts. Today, we're taking you on a journey to one of the most fascinating destinations in our solar system, Europa, one of Jupiter's largest moons, and the focus of NASA's thrilling new mission, the Europa Clipper. Scheduled for launch on October 10, 2024, this mission is one of the most anticipated space explorations in recent history. Why? Because beneath Europa's frozen surface, scientists think there may be a vast ocean that holds the key to unlocking the mystery surrounding one of humanity's most important questions. Are we alone in the universe? Europa is more than just a cold, icy moon. In today's video, we'll break down everything you need to know about Europa, the spacecraft set to explore it, and why this mission might change how we view our place in the cosmos. Buckle up, and let's dive into the icy depths of Europa. The Galilean moons. Before we get into the specifics of Europa itself, it's important to understand where it fits into the bigger picture of the Jovian system. Europa is one of Jupiter's 4 largest moons, collectively known as the Galilean moons, after the astronomer Galileo Galilei, who discovered them in the year 1610. These moons are Io, Europa, Ganymede, and Callisto. Each of them is unique and offers something different to the scientific community. Despite being only slightly smaller than Earth's moon, Europa has captured the attention of astrobiologists worldwide due to its hidden ocean beneath its thick ice crust. Ganymede is the largest moon in the solar system, even bigger than the planet Mercury, and has its own magnetic field. Callisto is heavily cratered, suggesting it has been geologically inactive for billions of years. Io, on the other hand, is the most volcanically active body in the solar system, with hundreds of active volcanoes spewing lava across its surface. The potential for life on Europa. So why is Europa so special? It's all about that ocean. Beneath Europa's icy surface, estimated to be around 10 to 15 miles thick, there is strong evidence of a vast, salty ocean that could be up to 60 miles deep. That's more than twice the volume of all of Earth's oceans combined. Why does this ocean matter? On Earth, we know that wherever there's water, there's life. Even in some of the most extreme environments, like the dark, frigid depths of Earth's oceans near hydrothermal vents, life flourishes. These are places where sunlight never reaches, yet complex ecosystems thrive around chemical-rich, heated water. Europa could have similar conditions. Scientists hypothesize that under Europa's ice, hydrothermal vents might exist on its ocean floor, providing the necessary heat and energy to support life. If microbial life or even more complex organisms exist, they could be living in a world entirely cut off from the surface, relying on chemical energy instead of sunlight. The Europa Clipper mission seeks to address 3 primary questions in order to investigate this possibility. First, what makes up Europa's ocean? Second, how thick is its icy shell? And third, is there any indication of recent geological activity that could push oceanic material to the surface? In order to determine whether Europa has the proper conditions for life, these questions are essential. A brief history of Europa missions. This isn't the first time we've studied Europa. Let's take a look at the missions that paved the way for Europa Clipper. In the early 1970s, Pioneer 10 and 11 made the first close-up observations of Europa. These early flybys gave us basic images and data, but the real breakthroughs came with Voyager 1 and 2 in 1979, which provided the first detailed images of Europa's surface. These images revealed an icy, fractured surface, unlike anything we had seen before. Then, in the 1990s, the Galileo spacecraft was launched, orbiting Jupiter and making multiple close approaches to Europa. Galileo's data was revolutionary because it showed that Europa's magnetic field interacts with Jupiter's to produce strong evidence of a potential subterranean ocean. This was revolutionary and sparked a resurgence of interest in lunar exploration. Following Galileo, NASA's Juno mission, which is currently orbiting Jupiter, has also contributed valuable insights into Europa's environment. Nevertheless, Europa Clipper is the first mission devoted to a thorough investigation of Europa itself, as Juno's primary focus is Jupiter. Mission overview and timeline. The Europa Clipper mission is unlike any that has come before it. Set to launch aboard a SpaceX Falcon Heavy rocket, the spacecraft will embark on a nearly 6-year journey to reach Jupiter's moon, Europa. After it's set to launch on October 10, 2024, it will perform a series of gravity assists, first with Mars in February 2025, and then with Earth in December 2026. These assists will help slingshot the spacecraft across the vast distances of space toward Jupiter, arriving in April 2030. When the Clipper reaches Jupiter, it will not circle Europa exactly. Instead, it will make nearly 50 close flybys of the Moon, each time gathering data while avoiding Jupiter's intense radiation belts. These flybys will allow the spacecraft to map 90% of Europa's surface in incredible detail while minimizing exposure to harmful radiation. Scientific instruments and their goals. Europa Clipper is equipped with a powerful suite of scientific instruments designed to explore Europa's surface, its icy shell, and the ocean beneath. Let's go over some of the key instruments and their functions. Firstly is the Europa Imaging System, EIS. This system will capture high-resolution images of Europa's surface, with a resolution of 1.5 feet per pixel during close flybys. These images will allow scientists to identify features like cracks, ridges, and chaotic terrain, which could offer clues about the interactions between the surface and the ocean below. Next is the Radar for Europa Assessment and Sounding Ocean to Near Surface, 𝐟𝐸𝐿. It is an ice-penetrating radar that will allow scientists to see below Europa's icy surface. By bouncing radio waves off different layers of ice and water, the radar will help determine the thickness of the ice shell and the depth of the ocean beneath it. Then we have the Mapping Imaging Spectrometer for Europa, MISE. This spectrometer will analyze the surface in visible and infrared light, identifying organic molecules, salts, and other compounds. By doing so, it will help scientists understand the chemical composition of Europa's ice and ocean. Also, there is the Mass Spectrometer for Planetary Exploration, Europa, MASSPEX. It will analyze gases from Europa's surface and atmosphere, particularly any water vapor plumes that may be ejected from the ocean below. This is crucial because detecting organic molecules in these plumes could provide the strongest evidence yet for the potential of life. Then there is the Europa Ultraviolet Spectrograph, Europa UVS. This instrument will search for evidence of plumes erupting from Europa's surface, similar to those seen on Saturn's moon Enceladus. If these plumes exist, UVS will help pinpoint their locations, making them prime targets for closer study by other instruments. Talking about the Plasma Instrument for Magnetic Sounding, PIMS. PIMS will study how Europa's ocean interacts with Jupiter's powerful magnetosphere. This will provide clues about the ocean's depth and salinity, helping us understand its potential to support life. 𝐸𝐴𝐷𝐼𝐴, or the Europa Thermal Emission Imaging System, comes last. In order to detect temperature variations, 𝐸𝐴𝐷𝐼𝐴 will map the surface of Europa using infrared light. Areas with higher temperatures may be those with more recent geological activity or those with liquid water near the surface. Potential for discovery and implications for astrobiology. So, what does all this mean for astrobiology? Indeed, the ocean surrounding Europa might be among the best places to look for life beyond Earth. Here on Earth, life can thrive in the most extreme environments: frozen tundras, deep ocean trenches, acidic caves, and even radioactive waste. If life has found a way to survive in these conditions, it's not far-fetched to think that it could exist in Europa's deep, dark ocean. What's especially exciting about Europa Clipper's mission is that it's designed to find signs of habitability, not just signs of life. In other words, it will help us understand whether the conditions on Europa are suitable for life to exist. By studying the ice shell, ocean composition, and potential interactions between the two, we'll get the clearest picture yet of Europa's potential to support life. If Europa does have life, it would most likely be microbial, similar to the microorganisms we find around Earth's hydrothermal vents, which survive off the chemical energy in their environments rather than sunlight. But even the discovery of simple microbial life would be groundbreaking. It would suggest that life might not be unique to Earth and that it could arise independently wherever the conditions are right. This would fundamentally alter our understanding of biology and our place in the universe. Delay due to Hurricane Milton. Due to Hurricane Milton's threat to Florida's Space Coast, the launch of the Europa Clipper was recently delayed. NASA and SpaceX gave the safety of the crew and the spacecraft top priority because strong winds and a lot of rain were predicted. The Europa Clipper was secured in SpaceX's hangar at Launch Complex 39A, while recovery teams evaluated conditions post-storm. The launch window remains open until November 6th, giving teams flexibility to find a new launch opportunity once the storm passes. The Europa Clipper mission represents a major leap forward in our quest to understand the universe. By studying Europa's ocean, ice, and potential for life, we're not only learning more about a distant moon, we're also gaining insights into the origins of life itself. Whether or not we find evidence of life on Europa, this mission will answer some of the biggest questions in planetary science and astrobiology. In the coming decades, we'll continue to explore our solar system and beyond, uncovering secrets that have remained hidden for billions of years. The discoveries made by Europa Clipper will inspire future missions, helping us push the limits of what's possible in space exploration. So, as we look forward to the launch of Europa Clipper in the coming month this year, we're reminded of one simple truth. The more we explore, the more we realize just how much is still out there waiting to be discovered. Keep checking back on our channel for updates on this mission and other innovative space explorations. Who knows? The discovery of life beyond Earth might be a cause for celebration one day. For more cosmic content, do not forget to hit the notification bell, like, and subscribe. Thank you for watching. Till we meet again, never give up looking up.